Let's do some transformations. Zara uses a rotation of 90 degrees clockwise about the origin. Now, what you should do when you're doing this question is get some tracing paper, draw the triangle, put your pencil on the origin, and rotate 90 degrees. Now, sometimes it is a good idea to just put a little arrow pointing up here, because then when you rotate it, you can stop when it's moved 90 degrees and is facing that way. Now I can't do that quite so easily, but I'll have a little go actually. Done that. Okay, I'm going to rotate it about the origin. You can see it moving, and I stop about there. Okay, brilliant. So this is my triangle. You then lift your tracing paper off, and you just do a little sketch of where your new triangle is, preferably with a ruler. I've done it a bit more quickly there. Okay, and then take away your tracing paper, and we're left with the triangle after the first transformation, followed by a reflection in x equals 3. Now x equals 3, where is that? This is x equals 3, but actually the whole way along here is x equals 3. So I'm going to do a dotted line. I mean, I don't know why I'm doing a dotted line, to be honest. Actually, I should probably do a nice solid line. There okay, that's better. And then I'm going to do, so yeah, basically it's where, when you get that sort of thing, it's you just draw a straight line through x equals 3. It will cross the x-axis. That's one way of thinking about it. Okay, so we're going to need to do a reflection. The first point will stay the same. This point will go 1, 2, 1, 2, will be here, and the bottom point will be there. And that is what it's going to look like. So that's my first, this is my triangle B. I'll write it next to it. I can't quite fit it inside. So draw and label triangle B. That's what I've done. Right, Sam does the same, well, gets the same triangle at the end, but does a reflection y equals minus x, followed by a transformation t. So let's have a little go at that. Y equals minus x, right, well, y equals x is this line up here. Y equals minus x is the one going this way. So this here, basically just make sure that the x value equals the negative of the y value. So this is y equals minus x. And now I'm doing a reflection. This is getting a bit messy, isn't it? But I'm doing a reflection of this triangle in the green line. It's going to be I need to be a bit more careful about this. So let's take the bottom point. I go diagonally 1, 2, because then I always go at right angles to the line. And I go another 1, 2. Okay, so it's going to go there. Same here. 1, 2, 3, 1, 2, 3. So it's going to end up here. And then this bottom right one, 1, 2 and a half, 1 and a half, 2 and a half. So that, there we go. Brilliant. What transformation's done to get to B? Well, they're in the same orientation now, so it's going to be a translation. A translation. I think we get away with just saying how many? 1, 2, 3, 4, 5, 6. So it's 6 to the right, and 0 up. If you want to be fancy, then you can write it in vector form, and it's going to be 6, 0. I believe it will be accepted if you say translation 6 units to the right and 0 units up. I'd say vectors are a good thing to get into because you will be expected to understand vectors anyway. And that is this question. I like it because it's testing transformations in a slightly different way. You're having to really, you have to do 4 transformations essentially, or 3 transformations and then work out the last one. Make sure you know how to do them. Rotations and reflections, and you know x equals 3 and so on. But yeah, that's the answer.